In this video, I'm going to show you the elimination method for solving systems of equations. So let's take a look at this system right here. What we're going to do with the elimination method is we are going to add both equations. What it means to add two equations is that we're going to add the terms on the left-hand side, and that sum is going to be equal to the sum of the terms on the right-hand side. So on the left-hand side, we have 3x plus a negative 3x, and that gives us 0. We have 4y plus a negative 6y, and that gives us minus 2y. On the right-hand side, we have negative 4 plus negative 6, and that's negative 10. So adding these two equations has eliminated the variable x, and so that's why it's called the elimination method. So what we're left with is this equation. So that says negative 2y equals negative 10. If we divide both sides by negative 2, we get y is equal to 5. Then to find x, okay, so when we're solving a system, we have to find the value of y and of x. To find out what x equals, we can just take this value of y equals 5 and plug it into either of the equations. Let's plug it into the first one. So we have 3x plus 4y, so 4 times 5, equals negative 4. So we have 3x plus 20 equals negative 4. Subtract 20 from both sides. So we have 3x equals negative 24, so x is equal to negative 8. So the solution to this system here is y equals 5 and x equals negative 8. Okay, let me give you one to solve. Okay, solve this system. Press pause while you work on it. So the first thing we're going to do is add corresponding sides of each equation. So we get 2x minus 2x, which is 0. 3y plus 10y is 13y, equals 5 plus negative 18, which is negative 13. Then we divide both sides by 13. We get y equals negative 1. Next, we're going to plug this value of negative 1 into the first equation to solve for x. Okay, so we get 2x plus 3 times negative 1 equals 5. 2x minus 3 equals 5. Add 3 to both sides to get 2x equals 8. Finally, we divide both sides by 2, and we get x equals 4. So the solution to this linear system here is x equals 4 and y equals negative 1. Sometimes you see solutions listed in coordinate form. Okay, so we could write this with the x value listed first, which is 4, and the y value listed next, which is negative 1. Okay, so your solution can be either expressed as a point here or simply in this form. Okay, here's a system where if we add corresponding sides of both equations, nothing is going to cancel out. Okay, so you see in this linear system right here, we have 3x and negative 3x, so if we add them, we get 0. In the next system, we have 2x and negative 2x, which if we add, we get 0. But in this one, we have 2x plus 4x is 6x, and negative 4y minus 5y is negative 9y. So what we have to do is we have to multiply the first equation here by negative 2. So we multiply the left-hand side by negative 2 and the right-hand side by negative 2. So then we get negative 4x plus 8y equals negative 26. And then we still have the same second equation, 4x minus 5y equals 8. Okay, so now we're just going to proceed as in above. So we add corresponding sides of each equation. Negative 4x plus 4x is 0. 8y plus negative 5y is 3y. And negative 26 plus 8 is negative 18. So now we just divide both sides by 3. And we get y is equal to negative 6. Now to solve for x, what we're going to do is we're going to take this value of y and plug it into either of these equations, or we can plug it into the very original equation. Okay, it's totally up to us, any form of the equations. So let's just plug it into this equation right here. We get negative 4x plus 8 times y, so 8 times negative 6, equals negative 26. So negative 4x minus 48 equals negative 26. Now we add 48 to both sides, so we get negative 4x equals positive 22. So x equals 22 over negative 4, which simplifies to negative 11 halves. Okay, so the solution to this system is x equals negative 11 halves, y equals negative 6. Okay, here's one for you to try. Why don't you press pause while you work on it? So the first thing you should do is multiply both sides of the first equation by 4. If you do that, then you get this for your system. So next, you should add corresponding sides of both equations. And you get 3y equals 9, which means y is equal to 3. Next, you plug this value of y into one of the equations to solve for x. Let's use this equation here. So we get 4x minus 5 times 3 equals negative 3. And if we solve that one for x, we find that x is equal to 3 as well. Okay, so the solution to this system right here is the point 3, 3. So x is 3 and y is 3. Okay, here's a case where no multiple of one of the equations gives us the number that we want. So in this case, we have to multiply both equations by a number. So let's make y our target variable. So that's the one I'm going to eliminate. So the question is, I need to multiply the negative 12 by some number and the 8 by some number so that they will cancel out. If I multiply the negative 12 by 2, I get 24. Well, negative 24. If I multiply the 8 by 3, I get positive 24, and that's going to cause the 2 to cancel out. So let's multiply the first equation by 2 and the second equation by 3. Okay, so if I actually multiply that out, I get 14x minus 24y equals negative 44 for my first equation, and negative 15x plus 24y equals 42 for my second equation. Now let's add corresponding parts of both equations. I have 14x plus a negative 15x gives me negative x. Negative 24y plus 24y gives me 0. Negative 44 plus 42 gives me negative 2. So I have negative x equals negative 2, which tells me that x equals 2. Now I plug 2 into any of the equations to find out what, for x, to find out what y equals. Okay, let's plug it into this original equation there. So I have negative 5x, so negative 5 times 2 plus 8y equals 14. So I have negative 10 plus 8y equals 14. I can add 10 to both sides, so I get 8y equals 24, which means y is equal to 3. So the solution to this original system right here is x equals 2 and y equals 3, which we can write in point form as 2